welcome everybody to the science of Minecraft. So my name is Sarah. I am the digital content producer for ROM School programs. I do stuff with Minecraft. And Kim, do you want to introduce yourself?
Yeah, happy to. So my name is Dr. Kim Tait. I'm the curator at the Royal Ontario Museum. I take care of all the rocks. So rocks, minerals, gemstones, meteorites at the museum.
Amazing. And also with us today is Alma, who is interpreting for our friends who need ASL. So if you are watching and you need to adjust the size of the video, there should be, if you're in Zoom, a little slider in between the screen share and our videos, and you should be able to move that around to be able to adjust the video size. And for anybody else, there will be in a few days, this will go up on the ROM's YouTube channel, and it will show all of our videos all at once. So if you need to come back and review anything, that will be there for you, hopefully by Wednesday. So welcome everybody. I don't know about you, Kim, but I am pretty excited to get started learning about the science of Minecraft.
I am so excited too. I don't know a lot about Minecraft, but I hear you do. So I'm really excited to talk about rocks and how it relates to Minecraft for sure.
Yes. So I can help with the Minecraft part and
I can help with the rocks part. So
yeah.
we're a great match.
Amazing. So before we begin, we do want to acknowledge that the Royal Ontario Museum is on what has been the ancestral lands of the Wendat, the Haudenosaunee Confederacy, and the Anishinaabe Nation, including the Mississaugas of the Credit First Nation from time immemorial to today. I'm really lucky at the museum. I get to work with Indigenous teachers who are amazing, and they teach us that whenever we acknowledge the land, it's also really important to reflect on your own connections to the land and how you got here. So I invite everyone to do that as we move on into our rocks and minerals. So I think the first thing that we want to go over is what is the difference between a rock and a mineral?
Well, that is an awesome question. So do you have some examples at your desk, Sarah, that we
I
can look at?
do.
That's so fun. I didn't bring any rocks or minerals today. I should have. So the difference between so mineral is natural occurring. It has a regular atomic structure and it has a fixed chemical composition. So typically they look very, homogeneous. They look the same. So I can tell right away that the sample in the middle of the screen is a mineral. There you go. And the one above it too is a mineral. But then you look on what is the right side of my screen. I hope that's the right for everybody, that one. Yeah. And it has different bits of it. So it has some black and it has some white and it has some pink, and that's a rock. So a rock is made up of minerals. That's really the only difference. So they're kind of related, kind of not, but all very fun in my opinion.
So is there a relationship between this rock and these minerals maybe?
For sure. So like I mentioned, rocks are made up of different minerals. So you can see that rock that is shaking on, on your table there has some shiny parts. And I don't know if you can tell so much in the screen, but micas have that nice flat surface, and those are minerals. So micas, if you could actually peel them apart layer by layer. I don't suggest you doing that to your nice specimen there, but it's almost like a book or a bunch of pieces of paper that are put together. And when it's flat, it has a really nice shiny surface. So that is what you're seeing in your rock there, is those shiny surfaces from the micas.
Awesome. So would it be something that might help our friends understand if we say like the minerals are the ingredients that go into a rock?
I think we could say that. Yeah.
Kind of like if you're going to make a cookie, you need to have all of your ingredients first.
You can't have a chocolate chip cookie without chocolate chips. It's true.
Awesome. All right. So let's talk about some different kinds of rocks, maybe. So let's start with igneous rocks. Where do we get igneous rocks, Kim?
So igneous rocks are from volcanoes. So our Earth is very dynamic. We have lots of different places where volcanoes are erupting. You can even watch volcanoes erupting on YouTube right now, which is live, which is super cool. These are lava that's spewing onto the surface of the earth. And that's what that image looks like there. You have molten rock, really, really hot, that is pouring out, and then it cools off eventually and turns into our extrusive igneous rocks.
Awesome. So here's our first Minecraft rock that we've already looked at a little bit. So this is our granite, and we saw that in the screen share. And one of the things that I wanted to ask you about, Kim, is that in Minecraft, you can get granite by combining diorite and quartz. So do we want to talk about the science there?
Sure. So granite is a very common rock found on the surface on Earth, but it's actually an intrusive rock. So it's found deep within our crust of our planet, but it is made up of three major components. It's made up of quartz, which you can see, which is awesome, and then feldspars and plagioclase. So those are sort of the big ones there. So yeah, I think that is actually pretty correct. Having the diorite rock plus a little quartz gives you a nice granite. And I love the textures that they used in Minecraft. I think that really shows off what granite looks like.
Yeah, you can definitely see that there's different things in the granite. How about diorite?
Mhm.
So in Minecraft, we have diorite looks very, very pale, and you can make it by combining quartz and cobblestone. So do we
Hmm.
want to talk about the science there?
Well, what is cobblestone, I wonder? So that's a different term than we're used to in geology, but
Mhm.
I think I get the idea of what they're trying to do there. So on the this one side there, we have a piece of diorite from our collections. So you can see really that black and white type of rock. And I think that's what they're trying to do there with the textures, at least, for sure.
Okay. And this is everybody's favorite when I'm talking about rocks and minerals. This is obsidian. And I'm going to actually switch to Minecraft. So here is our Minecraft world. And if I go over here, I have a nice pool of lava over here. And Kim, I want to show you what happens. And I want to see if you have any commentary on it. So I'm going to throw some water there. And then I'm going to clear this water away if I can. I'm stuck.
No.
There's my everyone but the source block. There we go. All
Okay.
right. So clear the water away, and now I have a little bit of cobblestone, and the rest has turned into Minecraft obsidian.
Ah, super cool. So the blocks, the red blocks there are lava. Is that what those are supposed to be?
Yep. So I had lava. This is a
Yeah.
magma block, which is a little bit
Magma
different.
block.
If I
Okay, got
stand
it.
on it, it'll hurt.
Don't stand
But
on
the
it. It's very hot.
lava, yep,
Yeah.
the lava, when I poured water on the lava, it turned into obsidian.
Yeah, that's very correct. So what's happening with the lava on the surface of the planet is that it's crystallizing very, very quickly. So if you look at it, you can see it almost looks like glass. And that's exactly what's happening there, is that it quenches or it cools very, very quickly and turns into a glass. So that shell kind of feature that has on there is called conchoidal fracture. And that would be the same thing if you were to break a pop bottle. You could
Oh,
see that
wow.
kind of feature. So it's just the atoms don't have enough time to really crystallize in a regular form, and so they form in such a way that's just kind of doesn't have any fractures or any way to break very evenly.
That's so neat. So when I'm looking at this obsidian, I'm not seeing different colors in it the way I do with the granite or the diorite.
That's right, because it's all just one mass of material, silica glass, that formed very, very quickly. So it didn't have time to make up those different components like your granite or your diorite did deep within the earth when it had a long time to slow cool. So you think of something like in a I don't know, in a pressure cooker that has all the time in the world to sort of crystallize compared to something that is, you pour something wet or water on it, immediately it crystallizes really fast. So those are the differences.
So the one other thing that I wanted to know about the obsidian is that, so if I'm in Minecraft and I'm in survival mode, so I don't have unlimited blocks, I have to mine everything myself if I want to use it. I can only get obsidian if I am using a diamond pickaxe, and it takes forever to get because it's the hardest block in Minecraft. So does the science match up to the real science there?
Certainly basalts and obsidians are quite hard. All the rocks that we've been talking about so far, the diorites, granites, those are all very, very hard rocks. I mean, that's why we make them, countertops out of them, because they're very durable and you can, cut your vegetables on them without scratching them. So yeah, I think that is pretty accurate.
Awesome. So you mentioned basalt, and so I wanted to share this one. So this is not in Minecraft Education Edition, which we're using, but it is coming soon to Education Edition, and some of our friends who play Minecraft regularly might know it already. So in Minecraft, we get basalt in the nether dimension, and so all across the nether, you have to watch out because you have these lava falls coming from the ceiling. But in one part, the lava has kind of gone extinct and formed these columns of basalt. And there's the basalt block up in the corner. So did you want to talk about that?
Yeah, I love basalt columns. Those actually form in real life as well. So there's a picture of it on the screen, and that's when the basalt is crystallizing, it actually forms these six-sided shaped sort of columns, I guess is the best word to describe them, as they're cooling. And it forms very similar to what you see in Minecraft. So yeah, that's very accurate.
That is so neat.
Oh, and that's a cool rock you have right beside it. That's called pumice. So that's another type of basalt, but it's a gassy basalt. I think that's probably the best way of describing it. It has a lot of gas bubbles in it and actually can float on water.
So I love that you mentioned pumice. I'm going to share the desktop again. So I have this piece right here. There we go. And I've always noticed that there's all of these holes in here and that this rock is super, super light.
Right. So it's very, very light. And some of them you can actually kind of crush in your hands because there's so much air pockets, air bubbles within the sample. And that's just from gas. That's all it is from CO2 gas and all these gases that are trying to escape, and they sort of get trapped in the lava and can't get out. So that is a very light, fluffy rock, and actually sometimes is used for abrasion purposes, on your rough feet, for example.
I can imagine it's really like
Really,
kind of sticks to my fingers when I touch it.
yeah, for sure.
So this one is my favorite, the rock that has my favorite name, and it's not in Minecraft yet, but it should be.
It
So
should
Kim, do
be.
you want to talk about this one?
I love these rocks. So there's different kinds of basalts, and they're based more on their appearance. So this one is called Pahoehoe, and that's just a fun name to say. And it's from how it crystallized. So it's forming these ropey tubes almost. You can see the picture in the middle there that the outer part has cooled off because it's interacting with the atmosphere, and then the underneath part of it is still molten, so it's still pulling and forming these ropes or tubes. And yeah, so Pahoehoe, and then there's Aa, which are two types of lavas that form in Hawaii. And yes, I think those should definitely be in Minecraft.
So cool. I think the closest we get in Minecraft is probably these magma blocks. So we put them all together, we can see some patterns in them, and if I stand on them, I'm going to get hurt. We can see, if I hold really still, you can see them actually moving around a little bit too. But that's about, I think, as close as we get in Minecraft so far.
No, that's pretty good though. I'm really impressed that they've come up with these these features and showing how you can crystallize into obsidian. I think that's really great.
All right, so let's talk about some sedimentary rocks. And in this picture, we have a little bit of a clue, I think, about how sedimentary rocks are formed. Did you want to talk about that?
Yeah, absolutely. So you can see, is that a fossil right in the middle there, I would imagine?
Yep.
I didn't know Minecraft had fossils. That's really cool.
It does.
Yeah.
This one I
So,
built, but you can find them
oh,
too.
okay.
We'll get
Okay,
into that
awesome.
in a bit, I think.
Yeah. So, I mean, that's an animal that was alive at some point and got buried with sediments over top of it. And over time, it's crystallized into some sort of rock. You can see there's different layers in this picture here. So we have some white layers, we have some brown layers, sort of tan layers in between. So I think that's very accurate of how sedimentary rocks layer up over time with sediments for sure. So we can either have siltstone, so really fine grained material, up to sandstone, so that's like beach sand that we find just at the beach, and kind of everything in between, even conglomerates or bigger chunks of rock that have been trapped into rocks as well.
I like that you mentioned sandstone because that's the next one that we have to look at. So in Minecraft, we have two kinds of sandstone. We have yellow sandstone and red sandstone, and you can find it out in desert areas. But you can also make it by combining sand together.
Yeah, that's very accurate. So just like I mentioned, the sand that you find on the beach over time, as it gets buried into more and more and more sand over top of it, it lithifies or it turns into a rock. And that's what we're seeing there is the sandstone rock. So that's great.
So sometimes when I'm wandering around in Minecraft, I can find a desert temple, and some of the blocks have been carved into what looks like the faces of creepers, which are monsters we can find in Minecraft. And I wanted to point that out because I noticed that we have some things in the Egyptian collections that are made of sandstone as well.
That's right. So sandstone is very soft, and you can actually, if you had a tool, you could be scratching into the surface. So that's what we're seeing there in the one that you're pointing out, is that somebody has obviously drawn in some messages and some images. So that is definitely what we can do with sandstone.
Amazing. All right, and we talked a little bit about this, but there are fossils in Minecraft. I built the one that we saw in the other picture, but sometimes in deserts or in swamps, you can actually find, these are bone blocks that are put together. This picture, one accidentally generated above ground, but I used it so that we can actually see what it looks like. And so I wondered if you wanted to talk about that. How accurate is that we find them under deserts and under swamps and nowhere else in Minecraft?
Yeah, no, that's very well, certainly in the sandstones, that's accurate. So there's a picture of my colleague, Dr. David Evans. He's the paleontologist at the ROM. And so he goes out and looks for dinosaurs in the Badlands of Alberta and in Montana. And he digs through the sediments to uncover these fossils. So that is absolutely true.
I noticed that in the rocks behind him, we can see sort of lines and layers.
Yeah, absolutely. So those are the sediments that are being built up over time to lithify the rocks, and that's what protects those fossils for us to uncover years and millions of years after. So that's a nice protection of those beautiful fossils that we can then see in the museum.
So cool. Okay, and let's talk now about metamorphic rocks. So there aren't that many examples that we have in Minecraft, but one of the big ones is Lapis Lazuli. So do you want to talk about this one?
Sure. So, I mean, this is such a striking sample. Typically in the collections that we have, it's this bright blue color, but it's a rock, so it's made up of several different minerals. So we usually see pyrite, which is that sort of brassy gold color. So I think you can see it a little bit in the sample there. I don't know if you can point it out.
There's some.
And yeah, and then calcite. So some of the white material is calcite, and yeah, it's got about most hardness of about 5 or 5.5. So it's very easy to with a tool carve as well. So that's a beautiful example of in the ROM's collections of a carving of lapis.
So you mentioned Mo's hardness. Is that like a guy named Mo who goes around and is like, it's that hard?
So we talk about, talc is very, very soft, and that's 1 on Mohs hardness, and then diamonds are very, very hard, and that's 10, and sort of this scale of hardnesses. So if I talk about a number, I can talk to other people that understand that that's sort of mid hardness. That's 5 is kind of halfway between talc and diamond, I guess is probably the easiest way to describe it without getting into a big lecture about it.
Is it like Mo like the name, or is it spelled differently?
It's MOH. Yeah, that's the name. And it's named after somebody. He came up with the whole hardness scale.
Awesome. All right. And then the other thing that we actually have in the Minecraft lesson that we built is marble. And it's not actually in Minecraft yet. So one of the technicians in the Earth Sciences department decided we were going to adopt Endstone and use it as marble. But Kim, do you want to talk about how we use marble in the museum maybe?
For sure. But before we do that, can't we break down the lapis into the different components?
Oh,
I think
yeah.
we talked about doing that, and I haven't seen that before in Minecraft. So that would be really helpful, I think,
Okay.
for me to see.
We'll do a Minecraft detour.
Okay.
So I have all of the rocks that we've seen so far laid out. I'm gonna pick up some sandstone, and I've got some lapis.
Okay.
So this right here, this thing right here is something that we have in Minecraft Education Edition. It's called the Material Reducer. And if I go into the Material Reducer and I put pretty much any of the rocks we've seen so far, so any of our igneous or sedimentary rocks in there, it's going to break down into silicone and oxygen, those 2 elements. And then
super cool.
If I take that out and I put the lapis in instead, it's different.
Very cool. So you can see the sodium, you can see the sulfur. Yeah, so that's actually very accurate of the different minerals that are made up of lapis. So that's really interesting. And I'm really glad that you're able to do that so you can understand a little bit more about what's in your rocks.
Silicone and oxygen, silicone and oxygen. Yay. And if I put grass block in there, carbon, oxygen, nitrogen, phosphorus.
Very cool.
All right. All right, so let's go
back. Okay, so back to marble. Sorry, I just remember
no, that was a
talking
great
about
detour.
that, so I wanted to see. So there's our rotunda. I miss our rotunda at the museum, but yeah, that's some marble flooring that we have, and actually the central part there is sodalite. So that's part of our lapis rock, one of the components of the lapis rocks. So all of that material was mined in Ontario. And I've actually been to those mines where you can have a look at them in real life and see how they were all put together. So this was a make work project in the 1920s to build this beautiful part of our museum. So that is made up of marble. And you can see that, yeah, there's some different colors in the flooring, and there's some different coloring in the block as well. So that is very true.
Awesome. All right, and then there is some other Minecraft stuff that we can explore as well. So one of the things that is coming soon to Minecraft are geodes. And in a Minecraft geode, you've got 3 layers. There's amethyst on the inside, and then there's calcite in the middle, and then there's smooth basalt on the outside.
Yeah, that's very accurate to how geodes are forming. Remember when I talked about our gassy bubbles in the volcanoes? It's very similar to how these form as well. We have the basalt outer rock, and some of these elements and minerals and gases all get trapped into basically a void, and they start to with enough time and enough elements present, they can actually form these beautiful crystals. So that's a picture from the ROMS collection, so you can see the purple amethyst crystals as well as the calcite growing there as well. So that is very, very accurate.
That's awesome. Now in Minecraft, a person is 2 blocks tall, which means I would, if I were in Minecraft, be able to walk right inside this geode. Are there geodes in real life that can get that big?
Definitely. Yeah, I've seen some that are the size of probably 3 people high that are for sale even. So yeah, I've seen some really, really large ones.
That is so cool. All right, and this is a very popular one. So we've got gold. And if I switch over real quick, I just wanted to show in Minecraft, we can find this gold ore.
Mhm.
And if I stick it in a furnace like this one, and I give it a moment, it will eventually give me a gold
Gold
ingot.
ingot. Very nice. So yeah, that's very true of how the rocks form here on Earth. If you take a ton of material from a gold mine, you might only get a couple of ounces of gold out. So if you look, that's the rock wall that we have at the museum. And I actually went to that mine and drove around with the mining engineer, and we found some really, really gold rich ore. But if you sit there and look at every bit, it's 5 tons of material. So that is a lot of material on that poor wall. We had to reinforce the wall a little bit to make sure it didn't fall through to the Canadiana gallery below. But if you look at those rocks, you won't even see gold because it's so tiny compared to the other rock that is formed there. But that's pretty much how it works, is that you have to grind up the rock, heat it up, and extract the gold out of the specimen.
So on the slide that we can see on our screen, there's a green circle around this little kind of white panel in the middle of the wall.
Yeah.
And it's hard to see because this is taken from so far away, but do you want to talk about what's in that little white square?
So when we do get back to the museum, I hope everybody gets a chance to look at that wall. So in that little box is a piece of gold ore, and that is the amount of gold that would be extracted from all those rocks on the wall. So that is sort of the visual representation of all the material, what you actually get out at the end.
So if Minecraft was like real life, I'd have to put like 100 of these blocks into the furnace to get a gold ingot out of it.
Yeah, unfortunately, but it looks like your gold block is quite rich, so that's good.
And iron does the same thing. So if I go back in here and I grab my iron and I put it in the blast furnace, this iron is going to give me an iron ingot.
Yeah, no, that's true too. So on the surface of our planet, we don't have a lot of free iron. What happens on big planets like Earth is all the iron sinks to the core. And so what we think is in the center of our planet is iron, is a solid iron core. And you can see there in the picture is a big chunk of iron, and that's an iron meteorite. So this is from a planetesimal, a planet that doesn't exist anymore, that has been ripped apart, and that is probably from a piece of the core of that planet.
Wow. Now it looks like there's a pattern in this iron.
So those are actually iron crystals. So that's what's forming in the center of this planet, where actually iron had enough time to grow into little crystals. And if you cut it flat and use some acid, you can actually etch out the crystal shapes and see them. It's called Whitman-Staton pattern. It's a hard word
Wow.
to say.
So iron has crystals. Does that mean that gold has crystals too?
Well, gold's a little different. I mean, it does have crystals, and we do see crystalline versions of it, which we have at the museum, and you can see it in the gallery. But gold likes to kind of fit in between other minerals. So you can see that white picture there, and I don't know which side it is on, so I don't really want to push it. Yeah, that one there is all that quartz. So the gold sort of likes to fit around all the other grains there, but it can do crystallized as well.
So
Gold is so fun.
we usually don't see gold crystals because gold is squishy.
It is squishy. It is a squishy mineral. It is makes it so fun.
So here's one that, at least in Minecraft, is the opposite of squishy. So in Minecraft, if we go down deep underground or into mine shafts, we'll find diamonds. So we mine the diamond ore and we will get a diamond out of it.
Mhm.
So how
Yeah,
does
so
that science measure up?
that actually is pretty accurate. So diamonds form deep within our planet's crust, and actually are brought to the surface by something called kimberlites. So these kimberlites are almost like a diamond elevator, if you will, to get diamonds from deep within the crust up to the surface where we can mine them. But carbon, which is the main element of diamonds, is on the surface is more likely to form graphite, which is in our pencils. So graphite is very, very soft. And that's why when you rub it on your paper, it actually leaves a mark. That is the graphite rubbing off onto your paper.
Wow. So One of the new updates is going to change it a little bit, but in Minecraft Education Edition, diamond tools are the hardest tools that we have in the game. And is that science accurate?
Sorry, I was trying to read as well. I'm sorry, Sarah, what was your question? Why are the...
Diamond tools are the hardest ones that
Yes,
we have in the game. And is that accurate?
that is accurate. So diamonds are extremely hard. So I mentioned the Mohs hardness scale. So these
Mhm.
are number 10. These are the hardest materials on Earth.
Awesome. All right, and emeralds are really popular in Minecraft as currency. So it's the closest we get to money. You can trade it with villagers, and you find them only in certain biomes. Like you really only find them underneath mountains.
That's very true. So my 5-year-old son told me that he loves me more than emeralds, and now I see why. Is because these are so rare in Minecraft. So yeah, so you can see they're beautiful green in real life. You can see some collection pictures there on the one side, and yeah, these form in very, very unique environments. Really, some of the best emeralds come from Colombia, and that's a Columbia emerald, where you see that really, really green color of the of the emerald. So that is the benchmark color for emeralds.
Wow. All right. And this is another one that is coming soon to Minecraft. So copper. And with copper, you can see in the picture in the middle, if you leave it over time in Minecraft, it will actually turn from this kind of shiny orangey brown to green. So what do we want to
That's
say about that?
That's very true. So you can see a picture right below it of Queen's Park, and they used copper sheeting for the roof. And instead of being sort of that coppery color that we expect from a penny, if people remember what pennies look like, or you can look at the images there from the gallery, sort of that coppery metallic look, it turns green over time as it's weathered. So that is very true.
So the other thing that I wanted to mention here, if we jump back into Minecraft, is again, in Education Edition, we don't have copper yet. It's coming eventually. You'll be able to do things like make lightning rods out of it. So if you put one on your house, lightning will strike the lightning rod and not set your wooden roof on fire.
That's
But
good.
what we do have in Minecraft is this stuff called redstone, which doesn't really exist in the real world. But I have a lever here, and this lever is a power source. So you can see it's kind of lighting up a little bit.
Okay.
I use this redstone to connect this power source to a machine like a piston or a door. It will actually carry that current and turn them on.
Is that a cow?
Yeah, I have a cow wandering around our testing
Okay,
site. I'm
just
sorry.
checking. That's it was a little distracting. I just want to make sure the cow was okay.
Yeah, cow's
Um,
fine.
yeah, so that is very, very true. So copper is used for wiring a lot, because it has a wonderful ability to transmit electricity through it. So that's what copper wires, how you turn on your light switch and your light goes on, is that electric current that is traveling through copper. So that is very true.
Wow. So this is another thing that is coming soon. It's not there yet, but it's coming. So when we go into Minecraft very soon, we will be able to find these things called dripstones hanging down from ceilings of caves and growing up from the bottoms of caves. And there's water that drips off of these dripstones, and you could put a cauldron under there and fill it up. So do we want to talk about these?
Yeah, so those are, I mean, those look very similar to stalactites and stalagmites, which form in caves. So yeah, it's just water dripping from the ceiling. And as that water gets to the tip, it then will drop onto the ground, and it actually can form sort of a reciprocal cone on the bottom. And how I remember which is stalactites has C, so it's ceiling for the roof, and then stalagmites has G for the ground. So those are the difference between the two, but they are very similar in formation.
Oh, wow. All right, so I think we've got a little bit of time left to see if there are any questions. And I know that a lot of people have got some. So I am just going to do this so that I can get at the questions. And there we go. Come back. All right, let's see. Let's start from the top. How does sand turn into glass by heating it?
Well, that's a really great question. So, I mean, the components of sand, if you were to go to a beach, the most common mineral that we find on Earth is quartz. So, if you were to put, again, a piece of quartz into your, what was your thing called there,
The
Sarah?
blast furnace,
Sure. Yeah,
a
or
regular
the
furnace, or the decomposer,
the
like the
decomposer.
material
That's what I was
reducer.
thinking about. So it's actually made up of silica and oxygen. And you can even make sure that I'm correct by checking in
Mhm.
your material reducer, make
There
sure
we
that
go.
I'm right. Yeah.
Yep.
So yeah, so if you were to then heat it up into the furnace, you would then get silica.
So I'm just gonna really quickly grab some sand
Okay.
and put that sand in this furnace. And we're gonna see what happens. This takes a little bit longer because blast furnaces go faster. But if I heat up the sand in the furnace, I get some glass.
Awesome.
So accurate science?
Accurate science.
Nice.
Absolutely. I like the question. Somebody's asking if rocks glow in the dark. So
Ooh.
that's a super question. So again, if you go to the gallery when it's safe and we're allowed to go back to the gallery, we have a corner in the museum that uses a special light to look at minerals in the UV in an ultraviolet spectrum, and we have rocks that do glow. So I invite everybody, again, when it's safe and we can get back to the museum, to have a look at our glowing rocks at the museum.
So I saw that there actually were a few questions about bedrock.
Okay.
Bedrock is a thing that you can get in Minecraft. I don't think I'll be able to place it now. Oh, no, I can. And this block, if you are in your regular survival mode, this block is completely unbreakable. You find it at the bottom of the world.
Yeah.
And it's what basically stops you from falling out into the void.
We don't want you to fall in
So
the void. Yeah, no,
no.
that's bad.
So I don't know, is there like a real world equivalent of bedrock?
Yeah, I mean, we think about trying to think of an example of where bedrock would come in. So if you have a cottage, and sometimes there's some sediments that are there first. If you were to dig underneath those sediments, eventually you would come to bedrock, sort of that solid ground of material. Ontario is covered with glacial sediments. So there was big sheets of ice that covered Ontario at one point, and all that those ice blocks ripped up our bedrock, and then as the ice melted, it deposited a lot of the rock and the sediments back onto the surface of Ontario. So you actually have to dig through the sediments to get down to the bedrock. But yeah, that's very accurate. It's very hard, and that's where you want to put your cottage on, is the nice, really strong structures of bedrock, for sure.
Awesome. There's a couple of interesting questions about gold. So the first one is, my class were very surprised to hear that gold is an essential nutrient. Is this true?
Yeah. So for us, or for plants, or is there any?
Just
Just in
essential
general,
nutrient.
essential nutrients. So yeah, no, gold is really important for a lot of reasons. So I mentioned, it's a squishy rock. I mentioned that, but gold has some of the most interesting properties of all the metals that we have. It would be used for wiring if it wasn't so expensive. So we could make all of our wiring and our walls out of gold, but it just costs so much. And there's talks about, prices of gold. Gold is used a lot for currency, for making ingots, like you mentioned in Minecraft. And so gold, unfortunately, has a lot of value to it. That's what we make jewelry out of, because again, it's very easy. It's malleable. It's very easy to, we talked about the squishy properties. But yeah, it's used for a lot of purposes for us externally, but yeah, it could be used for us internally and for plants internally as well. It's, I think a lot of elements in our atmosphere and in our soils are really important to all of us.
And the other question they had is, why does the price of gold go up and down?
It's a very complicated question that I don't have a lot of time for, but yeah, because it's used as currency. So we use it not only for for jewelry, and so for adornment. So looking at, people have gold rings and necklaces and earrings. It's a very prized metal. It's very hard to find, as we talked about, even in gold mines where it's concentrated. We can only get a couple ounces per ton of rock. So it's very hard to get out of our surface of our planet. And then when we do get it out, some people like to hold on to it because it's so precious and so rare. As times, currencies in governments can fluctuate up and down. We can watch how the US dollar compares to ours, and it's up and down, up and down. But gold's always going to be important and really rare. So people sometimes like to put it in their piggy banks for a long time.
So I see a question that I can answer. So the question is, my students are interested in learning about redstone. Is that in Minecraft only, or is there some sort of real life equivalent? And I would say the answer to that is, up until Minecraft actually got copper, redstone was kind of like the closest thing in Minecraft that we had for copper. It's a material that we could make wiring out of, but it is fictional. So I'll share my screen again, actually, so you can see where it comes from. So if I come back here, so we can get the redstone dust, but we find it down in the ground in the form of redstone ore, which looks like that. And when I'm mining, it actually glows a little bit if I'm standing on it, because you can see the little like particle effects that are coming up when I walk on it. Because you can actually squish it all together in a block. And when you put it together in a block, it becomes a power source itself. So that's powering that piston and making it go instead of the wire that carries a signal. So it's kind of used as the equivalent of copper wiring, but also a power source in and of itself. And I don't know, Kim, if you want to talk about, are there any rocks that we can find that would be a power source?
On their own?
Mm-hmm.
What are you thinking, Sarah? I'm trying to think of what you're leading at.
I don't know. I guess the closest thing I could think of would be like things that you might use in nuclear power.
Okay. Yeah. Oh, for sure. So we could use uranium, for example, in fuel rods. Yeah, that could be a good fuel source for sure.
Okay.
What is the nether? I don't even netherite.
Netherite is another coming soon. It is a fictional thing they have created. So I'm actually going to run back over to our material reducer, because this is kind of a really good way to illustrate it. So when I put a rock that actually exists, like diorite, I get the real elements that it's made of. Silicon is a real element, oxygen is a real element. But if I go and I grab something that comes from the nether, like we don't have netherite in education edition yet. Netherite is something you get from ancient debris. So it implies that there used to be a civilization that is no longer there, but you can sometimes find debris and refine it into netherite, which is this fictional thing. But if I stick this netherrack in the material reducer, I get silicon, oxygen.
Are you sharing your screen?
Oh, sorry.
I can't see it. So I want to see this fictional rock.
There we go. So if I put the netherrack in there, I get silicon, oxygen, mercury, and question mark. And question mark is the fictional material in Minecraft that we don't know what this is. It comes from another dimension, so it hasn't been defined yet. So it's not in Education Edition yet, but I am betting that when we get netherite and we put it in the material reducer, that we will get the question mark as well, because there will be something in it that doesn't exist on Earth. So that's my theory.
I like it.
Oh, there's so many.
So many questions.
So what is the closest thing to netherite in real life? So the thing about netherite is that it is even harder than diamonds. So your armor will last longer, your tools will last longer. So is there anything that we have that is harder than diamonds?
No.
So that's where that
So
question mark is
I think
coming
that's where the question mark comes in. Yeah.
Oh, this is a good question. Why does copper turn green over time?
Yeah, it's just it's a complicated process, but the copper mixes with oxygen and makes a different mineral. So that's what's happening.
So unfortunately, I think this is the end of the time that we have. That went by so fast. Oh my goodness.
There's so
So
many questions we didn't get to, but we'll
I
have to do
know.
another time. Maybe we can talk more about Minecraft.
Yep. So again, I want to say thank you so much, everyone, for joining us. And thank you so much to Barrick for sponsoring the Minecraft program so that we can do cool sessions with you like this. Thank you so much, Kim, for all of your expertise. Thank you, Alma, for helping all of our friends. And we really hope that we will see you again. Thank you so much, everybody, and enjoy the rest of your day.